Hi, these are notes about gas stoichiometry. So the cool thing about gases is that it doesn't really matter what gas it is. So it doesn't matter like what the molar mass of the gas is. They're going to always have, they're always going to occupy the same amount of volume at the same temperature and pressure. So it won't matter whether we're talking about carbon dioxide or hydrogen. If we're at a specific temperature and pressure, we'll have the same amount of those, each of the gases. And that what we're using is the fact that 1 mole of any gas at standard temperature and pressure, remember that would be 0 Celsius, 1 atm, is going to occupy 22.4 liters. So that's about 11 2-liter bottles of soda or whatever, but would be made up of some kind of a gas. And then SRC, remember, is room temperature, so it's 25 Celsius and 1 atm. So this is going to be a little bit larger volume, but again, it doesn't matter 1 mole of any gas as long as it is at that same temperature and pressure. A mole of carbon dioxide, a mole of chlorine, they're going to be taking up this much volume. So if you don't have your mole map, I would go get it and pause the video. So we know we can use Avogadro's number. We know we can use molar mass. Same thing over here. And we also are really good at doing our mole-mole ratio. So remember, we take those coefficients from the balanced equation. So we're going to build on that now, and we're going to come down here. So if it's a gas, and sometimes I write a little balloon, because later there's another type of volume on the mole map too. But so we're talking about gases. We can use the equality that 1 mole of a gas is 22.4 liters. So if I'm converting this direction, I would write 1 mole on the top over 22.4 liters, because then that would get me to mole. Or if I am talking about SRC, it would be that 1 mole over 24.5 liters. So I would label your mole map. And then it's also possible once you come over here to a new substance, then you're going to have the volume on the top. So it would be either this or 24.5 liters per mole, depending on whether we're talking about SRC or STP. So I'll just do one example, and then later in the page there are more examples of me doing calculations. So for this calculation, we have 6.83 liters of oxygen at STP, and they're produced according to this reaction. And the question is asking, how much ammonium nitrate would I need? It doesn't tell me like what value, but I would assume, since it's a solid, that we're talking about grams. That would be like a reasonable thing that I could go in the lab and measure out. So we're starting here at liters of oxygen, and then we're going to want to convert to moles of oxygen. Then we're going to convert using the mole-mole ratio to the moles of ammonium nitrate. And then we'll use molar mass to get to the grams of ammonium nitrate. So, we've done problems like this. The only new part is for this question is just this first step. So like we've always done, we're going to write that beginning number always over 1 on the far left of the problem. Then now I'm going to remember STP means that 1 mole of any gas is 22.4 liters of volume. I'm going to put the 22.4 liters of oxygen, it could have been any gas, for every 1 mole of oxygen. So then I can see that my liters cancel and I'm at moles of oxygen. So I'm right here. Now I'm going to convert over to the ammonium nitrate by using that mole-mole ratio. So I always do this just to really point out that I'm taking those coefficients from here. So I would want to have 2 moles of ammonium nitrate for every 1 mole of oxygen. And then you can see those cancel. I'm right here now. I'm at moles of ammonium nitrate, and then I just wanted to figure out how many grams this is. So now I would just do the molar mass. 1 mole of ammonium nitrate has a mass of 80.06 grams. And then I would just crunch the numbers. And I think, yep, I get about 45.6 grams. It might be different because this question back here has they went out further with the molar mass, but it should be about that value. So that is how you do stoichiometry, and there are more examples if you watch the video after.